So let us have a look at this problem. Here, this is um, let us write in this form f of t into y and the function of x. Okay, so this and then we write this is equal to 0 to get the complementary function. Okay, so let us do that first. Okay, so this is t square minus 4 into y is equal to 0. The auxiliary equation corresponding to this is m square minus 4 is equal to 0, or the roots of this is plus or minus 2. So you got yc, which is the complementary function, which is c1 e to the power of 2x plus c2 e to the power of 2x. Okay, minus 2x and plus 2x. So let us find yp. So yp will be now this is I mean uh, 1 by d square minus 4 into cos h of 2x minus 1 plus 3 over x. Okay, so let us take this entire thing as p1. Okay, this thing as p2. Okay, let us find this. Okay, so p1, as I said, is equal to cos h of 2x minus 1 divided by this is d square minus 4. So cos cos hx is e to the power of x plus e to the power of minus x by 2. So here x refers to as 2x minus 1. So this will be e to the power of uh, 2x minus 1 uh, plus e to the power of minus of 2x minus 1 by 2. Okay, so this is with respect to cos, okay, multiplied into d square minus 4. Okay, so let us evaluate this. Okay, now when I substitute uh, d as a, which is e to the power of 2x, when you look into this, here a is 2, so d as 2, the denominator goes to 0, so denominator goes to 0. So now uh, for this case, let us see what happens. So we'll separately do it. So 1 by 2 e to the power of 2x minus 1 divided by d square, okay, minus 4. Okay, so let us see that. Yeah, look at that. So says 2 e to the power of minus 2x, okay, to the power of 1. Okay, separately I can write this. To e to the power of minus 1. Okay, so this will be d square minus 4, right? So as I said, when I substitute this d as 2, so denominator goes to 0 for both sides. So when the denominator goes to 0, uh, you take this f of d, which is d square minus 4, differentiate with respect to d, so you get this as 2d, and multiply uh, x in the numerator. So this will be 1 by 2. Okay. So x into e to the power of 2x minus 1 by um, 2d. Okay, fine. This is 1 by 2. This is x e to the power of minus 2x minus 1 by 2d. Okay, so again substituting d as 2 and here d as minus 2. So let us substitute it. So this is 1 by 2 is 1 by 4 if you take it. So this will be e to the power of 2x minus 1 divided by 2. Okay, and this is minus by 2. Okay, so 4, right? So x into e to the power of minus of 2x minus 1 divided by minus 2, right? So let us combine these two, right? Okay, 1 by 4, I can take it outside. Okay, this is x. Okay, don't forget that. Okay, I can take even x also outside. So x by 4, right? So this will be x by 4 of e to the power of 2x minus 1 minus e to the power of minus of 2x minus 1 divided by 2. Or now sine h of x is e to the power of x minus e to the minus x by 2. Okay, here x is 2x minus 1. So which is x by 4 sine h of 2x minus 1. Okay, so we got the first particular here. Second would be 3 power x by d square minus 4. Okay, so which is e to the power of x log 3. Okay, by d square minus 4. Or now substitute d as log 3, right? Since e to the power of ax, okay, is e to the power of this x log 3, right? So a is log 3. Okay, let us substitute it here. So we don't require again this. So I'll replace this as 3 power x again. So this is log 3 square. Okay. So y is equal to yc plus y. Okay. So have a look at this problem. This is the type of Legendre linear equation. Okay. So the general form of this is ax plus b to the power of n d power n or n minus plus uh, ax plus b k power n or sorry the first term k1 uh, that is n minus 1 y to the power of n minus 1. Okay, and kn. Okay, y is equal to x. Now here the x is the function of x. Okay, x is the function of x. Okay, here it is 6x. Okay, so for now this is of a Legendre's linear equation. This has to be reduced in the form of linear equations, okay, uh, which we obviously f of t into y is equal to the function of x, okay. So in this form, right, we are going to reduce this. So what are we supposed to do is we um, we take these constants ax plus b as we substitute that into e to the power of e to the power of z. Okay, we'll represent this as z or t. Okay, and which is uh, log of uh, log of ax plus b, which is z. Okay, right. Okay, here what I represent this as 2x plus 3, okay, which is e to the power of z or log of 2x plus 3 as, okay. So this is the first thing which I'll be substituting it. Also, now you have this y double dash, this whole square and so on. So that has to be reduced in d to the power of n y and the constant. Okay, so dn minus 1, right? N minus 1. We have to reduce in this form. Okay, which has to be reduced in this f of t of y is function of x. So, uh, so here it is ax plus b, okay, which is the general form dy dx as a into d1 y, and uh, and so it is power square, right? So that would be ax plus b square d square y by dx square. So that is a square into d minus 1 y. So corresponding to that, we have 2x plus d, right, to d. Okay, I'll not take y, which is common on both sides. So a here ax plus b, so x plus 3. So here a as 2 and b as 3. Okay, by this. So this is 2d1. Okay, and here we have 2x plus 3 whole square d square y, which is a square, which is 2 square d1 d1 minus 1, okay, into y. Okay, so let us substitute that, okay, in the given equation. So the given equation becomes 4 d1 d1 minus 1 minus 2 into 2 d1 minus 12 into y, okay, which is equal to 6 times half of e to the power of z minus 3. So further simplifying this, okay, so this is 4 d1 square minus 4 d1 and 4 d1 is 8 d1, okay, let me, this is 8 d1, okay, minus 12. this whole thing into y is equal to this when you simplify, this is 3 e to the power of z minus 9. Okay, so now it is in the form of f of dy into the function, right? Again, here the function itself. Okay, so we equate to 0. So when I equate this is 0, you get the complementary function, that is yc. So um, the auxiliary equation corresponding to this will be 4m square minus 8m minus 12 is equal to 0. Or when we simplify it, you get further m square minus 2m minus 3 is equal to 0. Or the roots are 3n minus 1. Okay, so now this is yc, uh, c1 e to the power of minus z plus c2 e to the power of 3z. Okay? Or this can be written as uh, as we know that we have taken that as this will be uh, to the power of, right? So it is c1 2x plus 3 to the power of minus 1, and c2 is 2x plus 3 whole square, whole cube 3z. Okay, so we got yc. Okay, now for yp, let's do it. So this is your yp. So you are substituting d1 as 1 here, and d1 as 0 here. So this is 3 e to the power of z divided by, uh, this will be 4 uh, and minus 8, and this will be minus 16. Okay, and this would be 9 by 0 and 0, and this is minus 12. Okay, it's 12. So we can put this together as minus 3 by 16 e to the power of z uh, plus 3 by 4. Okay, so this is your yp. So or in terms of x, the function of x, so this is minus 3 by 16, 2x plus 3 plus 3 by, so y is equal to yc plus y. Okay. So look at another problem wherein you have this. This is called as Cauchy's linear equation, which is of the form a n x to the power of n dn plus a n minus 1 x to the power of n minus 1 d to the power of n minus 1. Okay, and this is a naught, and this is into y is the function of x. Okay, so now here we present x as e to the power of t, and t will be log x or log x, right? So let us have a look at, and also we have dy as x dy as xd, which is d1. Okay, okay, or and d square y, uh, which is uh, x square d square. Okay, which is d1 minus 1. Okay, so let us have a look at that also. So as I said, uh, this is d1, right? So and since you have cube, so d cube by which is just x cube d cube. Okay, just d1 1 into d1 minus 1 into d1 minus 2. Okay, so with respect to y, so that's y. So let us substitute all this, right? So that is d1 into d1 minus 1, d1 minus 2 into y. Okay, I'll take y as common, plus 2 into d1, d1 minus 1, okay, plus 2 into y. This whole thing is a function of y. Okay, so which is equal to, uh, as we have taken x as e to the power of t, so this is 10 e to the power of t, and 1 by x, which is e to the power of minus t. So yeah, we have come to everything here. So now let us simplify this. So we do this, you got the inner, that is d cube minus d square, d1 square, okay, plus 2 into y is equal to 10 into e to the power of t plus e to the power minus t, right? Now, the first thing is of d1 y is equal to 0, okay, to get the complementary function. So here the auxiliary equation corresponding to this will be m cube minus m square plus 2 is equal to 0. Now we find the roots of this equation, cubic equation, which is m is minus 1 and m as 1 plus or minus I. Okay, so that uh, done. So you write yc as c1 e to the power of minus t plus e to the power of t. Okay, this will be c2 cos t plus c3 sin t. Okay, so yp. So yp, or we can write this further, okay, in terms of x, which is e to the power of t minus t, which is c1 by x. Okay, c1 by x. So is x to now power of t, which is x, right? So what we have here, log of x as t, right? So c2 cos of log x, okay, plus c3 sine of log x. Okay, it's yc. Okay, this is your yc. So let us see what is yp here. So yp is 10 multiplied e to the power of t. Okay, let me separate it. 10 into e to the power of t divided by d cube minus d square plus 2 plus 10 e to the power of minus t divided by d cube minus d square plus 2. Okay, so here substitute d as okay, either you can take d or d1. Okay, so since I've taken d1, okay, d1 as 1, let us substitute here d1 as minus 1. Okay, so as you see here, if I substitute um, here d as 1, so this is 10 divided by 1 minus 1 plus e to the power. Okay, and if I substitute d as minus 1, you can see that denominator goes to 0. So this is minus 1 and minus 1 plus 1. So this is 0. So multiply with d, okay, and e to the power minus t, and differentiate the denominator. So f of d1, which is d1 cube minus d1 square plus 2. So f dash of this will be 3 d1 square minus d1. Okay, so 3 d1 square. So here, which is 5 e to the power of t, okay, which is done. Okay, now let us substitute here d1 as minus 1 again. Okay, so this is t into e to the power of minus t divided by, this is 3 minus minus plus. So this, forget 10. Okay, 10 is there. Now this will be 5 e to the t plus 2 t e to the power of minus t. Okay, this is your y. So y is yc plus y. This you can further write this as e to the power of t is x. So this would be 5x, and this will be 2 by e to the power of t, which is x, right? And log x. So this is the final y. Okay. So y is equal to yc plus y.